Today, we're going to talk about something really cool. We're going to look at a project that takes a tiny little computer chip, the kind of thing hobbyists and makers love to tinker with, and gives it the keys to a massive piece of industrial machinery. It's an awesome story about bridging a huge gap with some clever problem solving.
I mean, it sounds kind of crazy, doesn't it? How can a little chip you can buy for a few bucks have what it takes to reliably run some heavy-duty, expensive equipment? Well, that is the big question, and that's exactly what we're going to unpack in this explainer. So to really get why this is such a big deal, we first have to understand the massive difference between the world of DIY electronics and the super demanding world of industrial automation. Okay, so in pretty much any factory, on any assembly line, or even in a giant piece of farm equipment, there's a thing called a programmable logic controller, or a PLC for short. You can just think of it as the super tough, super reliable brain of the machine. It takes in information and tells the machine exactly what to do day in and day out. Now, on the complete other end of the spectrum, we've got the hero of our story, the ESP32. This thing is a powerhouse microcontroller that's cheap, easy to get, and incredibly popular with makers and hobbyists. The hardware's there, it's capable, and the potential is just enormous. But here's the catch. This is the big problem. You could find lots of ESP32 boards that were called PLCs, but they all had to be programmed the old-fashioned way, writing lines and lines of C++ code. What they were all missing was the software that real industrial pros use, a visual environment where you drag and drop function blocks, kind of like building a flowchart. That professional-grade tool just didn't exist for this hobbyist chip. So this missing piece sent a team of developers on a real quest. They had the powerful hardware, the body if you will, but now they needed to find the right industrial-strength brain to make it all work. And they were really methodical about it. They looked at Code Sys's, which is a huge name in the industry, but nope, it didn't support the ESP32. They checked out Logic Hut, but trying to get it to work would have been way too expensive and complicated. The OpenPLC project was out there, but it was running on old tech and was missing a really important feature, which we'll get to in just a second. And then they found it. Eclipse 40Ac. This was the one. It hit every single mark. It was open source, so it was free. It was being actively developed, which is a huge plus. Someone had already done the initial work to get it running on the ESP32, and most importantly, it had that absolute killer feature they needed, a real monitor and watch mode. Okay, so with the software finally picked, let's take a closer look at how this whole Eclipse 40Ac thing works and what exactly makes it so perfect for this job. You know, the best part about the 40Ac system is just how simple it is to use. First, you install the runtime on the chip one time. That's kind of like its operating system. But after that, you send all your new programs and updates to it over Wi-Fi. No more messing with cables every time you want to tweak something. And then you can just sit back and watch it all happen live. And that monitor and watch feature, honestly, it's the real game changer here. Think about it. Trying to figure out what's wrong with a complex machine when you can't see what its brain is thinking is a nightmare. This feature is like hooking up a live EKG to the machine's logic. You see every single input, every output, every decision as it happens. It makes building and troubleshooting so much faster. One of the developers, Franz Hinker, really nailed it with this quote. The whole idea is that what you see is what you get. That clean, visual diagram you build on your computer screen, that is the program. It isn't getting translated into some other complicated code. The diagram itself is what's running directly on the chip. But of course, brilliant software is only one part of the equation. If you're going to control heavy machinery that lives out in the real, messy world, you need hardware that can actually handle it. And this is where all those standard, off-the-shelf ESP32 boards just couldn't keep up. A lot of them didn't have enough extra memory, called PRAM, to handle the really complex control programs. They often use these slow, clicky mechanical relays instead of modern, super-fast, and durable MOSFETs. And for farming equipment, they were almost all missing a CAN bus port, which is the standard way tractors talk to the tools they're pulling. So the team did what any great engineers would do. They just built their own, and they went all out, designing a whole lineup of custom hardware. Everything from little modules that snap right onto an industrial rail, all the way up to completely waterproof controllers designed to live outside in the rain and mud. All right, so now we have the perfect software and we have the perfect custom hardware. So what happens when you put it all together? Let's see what this actually looks like in the real world. So this right here is the control station for a giant slurry tanker. On the left, you see the before. A massive, clunky box full of switches, a mess of wires. It was so big it literally blocked the driver's view at the back window. Now, look at the right. That's the after. One clean, simple touchscreen with a modern interface. What a difference! I mean, just imagine being the person who has to operate this thing all day. The improvement is night and day. Suddenly, their view is totally clear, which is way safer, and instead of flipping a dozen different switches, every single function is now intuitively mapped to a modern joystick. The whole job just became easier, safer, and a lot less tiring.
Now let's just zoom out for a minute and think about the big picture here, because this isn't really a story about just one upgraded machine. It's much bigger than that.
What this whole project really proves is a powerful new idea. When you take affordable, easy-to-get hardware like the ESP32 and you pair it with powerful, free, open-source software like Eclipse 40ac, you've basically created a recipe for innovation that can bring even the most old-school industries into the modern age.
And that kind of leaves us with one last big question. We've seen what this combination can do for a farm. So what's next? What other industries, what other complex, expensive, or outdated machines are out there just waiting for a transformation like this? When you think about it, the possibilities are pretty much endless.